Okay, on this question, we are dealing with rational expressions and we want to break them into partial fractions. In order to do so, we're going to solve A and B as an example, and the rest can be solved at your own convenience. So on A, we have 5x minus 1 on the top. On the bottom, we have x plus 1 times x minus 2. In order to break this into partial fractions, we're going to say, on the denominator, we have two linear factors in here. So each of these linear factors is going to have its own term. So we can break this into a over x plus 1 plus b over x minus 2. And now if we find the a and b value, we can say that we can successfully actually broke this expression into two partial fractions. Now, in order to find the a and b value, we first need to get rid of the denominator. So we're just going to multiply both sides of the equation by the common denominator, which is the multiplication of x plus 1 and x minus 2. So what we're going to do, we're just going to rewrite the equation in here, and we're just going to multiply each of the expressions by the common denominator. So on the left-hand side, we had 5x minus 1 over x plus 1 times x minus 2, and we're just going to multiply it by x plus 1 times x minus 2, which would be equal. We're going to do the same thing for each of the expressions again. We have a over x plus 1. That's going to be multiplied again by x plus 1 times x minus 2. And on the last expression, we had b over x minus 2, which is going to be multiplied by x plus 1 times x minus 2. And now we're just going to simplify the expressions. As you see in here on the left hand side, we have x plus 1 and x minus 2 both on the top and bottom, so these are going to be cancelled out. And on the right hand side, for the first expression, we have x plus 1 on the top and on the bottom, so these would be cancelled out. And on the last expression, we had x minus 2 on the top and on the bottom, which would be cancelled out again. Now we're just going to rewrite and expand the brackets as well. So on the left hand side, we would have 5x minus 1. On the right hand side, we have a times x minus 2 in the bracket. In order to expand it, we're just going to multiply the a value in here by each of the terms in the bracket individually. So we have two terms in the bracket. The first one is x and the second one is negative 2. So a is going to be multiplied by each of these terms individually. For the b, the same thing is gonna happen. So b is going to be multiplied by x and by plus 1 in here. So we're gonna just write the equations. So we have a times x on the first term. The second term is going to be a times negative 2, which would be equal to minus 2a. And on the last expression, we have bx plus b. Now, in order to get the a and b value, we have to match the coefficients in here. In order to match the coefficients, we have some x terms on the left-hand side, as you see in here, and we have some constants on the left-hand side and right-hand side as well. So we're going to just match the coefficients of the x terms, and we are going to match the coefficients of the constants as well. So on the x terms, we have 5x on the left hand side, we have ax and we have bx. So we can say that 5 would be equal to a plus b. And for the constants, we have negative 1 on the left hand side. And on the right hand side, we have, as you see in here, negative 1, and we have negative 2a and plus b. So we can write this as negative 2a and plus b as our constants. Now we have two equations number 1 and equation number 2, and we have two unknowns. So we are going to solve this and find the value of a and b in here. Based off the first equation, we can say that b value would be equal to 5 minus a. So you basically just move a to the left hand side and its sign would be actually changed to a negative sign. And the second unknown, second equation here, we have negative 1 is equal to minus 2a plus b. But instead of writing b in here, I'm just going to write the b value that we got from the first equation. So I'm just going to replace it with 5 minus a. Now, based off this equation in here, we have minus 1 is equal to minus 2a plus 5 minus a. And based off this, we can say that we have minus 2a and minus a on the right hand side. So it would be minus 3a. And if you just move 5 to the left hand side, it would be equal to negative 5. So we have negative 6 on the left hand side. And our a value based off this would be equal to 2. Right? And to find the b value in here, I'm just going to substitute the a value from the first equation to get the b value, right? And based off this equation, we can say that our a value would be equal to 2. So our b value would be equal to 5 minus 2, which would be equal to 3. So we just use the first equation to get the b value. Now, we found our a and b value in here, so we can now find the partial fraction value. So let's go back to the top. We had a over x plus 1. Our a is equal to 2, so now we have 2 over x plus 1 as our first partial fraction, and our second partial fraction would be equal to b over x minus 2, and our b would be equal to 3 over x minus 2. And we would be done with the a part. Now on the b part, it wants us to check the answer by adding the partial fractions together. So our partial fractions was this, and now I'm just gonna add them up to see if I can get the same expression that we had on the question. So we are dealing now with two fractions in here which don't have the same denominator, as you see in here, x minus 2 and x plus 1. In order to add these fractions together, what you should do is you should find the least common denominator first in order to add them up. The least common denominator in here would be equal to x plus 1 times x minus 2. Basically the multiplication of the denominators. So I'm just going to write the least common denominator in here. Now, in order for the first fraction to have the same least common denominator in here, it needs to be multiplied by x minus 2 because it already has the x plus 1 term in here. It just needs the x minus 2 term on the top. So it's going to be multiplied by x minus 2. And for the second fraction, it needs to be multiplied by x plus 1. Now we're just going to expand the brackets. So 2 times x, 2x, 2 times minus 2, minus 4, 3 times x plus 3x, 3 times 1 plus 3, and the denominator we have the x plus 1 times x minus 2. So on the top, we're just going to add the x terms, which is 5x, and now we're going to add the constants, which is minus 4 plus 3, minus 1. And on the denominator, we're going to have the same terms. And we're going to check if this expression is the same as the question, which is the top is 5x minus 1. And we can see we had 5x minus 1 on the top as well. On this question, again, we are dealing with rational expressions and we want to break them into partial fractions. We're going to solve C as an example and the rest can be solved at your own convenience. On C, we have minus 3 over 2x plus 1, x minus 3. As you see in here, in the denominator, it consists of two linear factors. And each of the factor has its own fraction. So it can be separated as a over 2x plus 1 plus b over x minus 3. So a constant on denominator and the factor itself on the denominator. Now we want to find the a and b value in order to find the partial fractions. In order to get the a and b value, we have to get rid of the denominators in here first. So we're just going to multiply both sides of the equation by the common denominator. And the common denominator is here is 2x plus 1 times x minus 3. So we're just going to multiply both sides by this value in here. So the left-hand side, we had minus 3 over this expression. I'm just going to multiply it by 2x plus 1 times x minus 3. And we're going to do the same thing by each of these terms. So it is a over 2x plus 1, and it's going to be multiplied by 2x plus 1 times x minus 3. And the last term, we had b over x minus 3, which is going to be multiplied by 2x plus 1 times x minus 3. After that, we're just going to simplify the expressions. So on the left-hand side, we have 2x plus 1 on the top and bottom, x minus 3 on the top and bottom. These would be cancelled out. On the right-hand side, 2x plus 1 on the top and bottom would be cancelled out. And on the last expression, we had x minus 3 on the top and x minus 3 on the bottom. These would cancel out each other as well. Now we just need to write the equation. So we had minus 3 on the left-hand side. On the right-hand side, we're going to expand the brackets. So a is going to be multiplied by x and negative 3 individually. So a times x is ax, and a times minus 3 is equal to minus 3a. b times 2x, it would be equal to 2bx, and b times 1 would be equal to b. As you see in here, now we have to match the coefficients. We have to match the coefficients of the x terms and the constants. So on the x terms, as you see in here, we don't have any x term on the left-hand side, so it would be equal to 0. But on the right-hand side, we have multiple, or two, I should say, x terms. The first one is a, and the second one is 2b. As you see in here, a and 2b. These are the x terms. Now let's head to the constants. On the left-hand side, we have one constant, which is equal to negative 3. And on the right-hand side, we have two constants as well, which is minus 3a and plus b. So we're just going to write minus 3a and plus b. Now, basically, we have two equations, equation number 1 and equation number 2, and we have two unknowns. So we're just going to solve this system in here. Based off the equation number 1, we can say that our a value would be equal to minus 2b. So basically, I just moved 2b to the left-hand side, so its a sign would be changed to a negative sign. And in equation number 2, we had minus 3 is equal to minus 3 times a. Now, instead of a, I'm just going to use the value of a that we got from equation number 1. So it was minus 2b plus b itself, based off the equation number 2. Now I'm just going to solve this equation in here. We have minus 3 is equal to minus 3 times minus 2b is equal to 6b. And we have b in here as well. Now, based off these equations, we can say that our b would be equal to, we have 7b on the right-hand side and minus 3 on the left-hand side. So b would be equal to minus 3 over 7. Now, I'm just going to substitute this b value onto equation number 1 to get the a value. So we have a is equal to minus 2 times our b value, which will be got based off equation number 2, which is minus 3 over 7, which would be equal to 6 over 7. So now we got the a and b value, so we can write this equation as a, we're gonna just move to the top, and our a value would be equal to 6 over 7 over 2x plus 1 plus b, which was equal to minus 3 over 7 over x minus 3. And now what you can do, you can bring the 7 on the bottom as well. I write this as 6 over 7 times 2x plus 1 plus minus 3 over 7 times x minus 3. And now you can just expand the brackets on the bottom and the top as well. So you can say that this would be equal to 6 over 7 times 2x would be equal to 14x plus 7. And the bottom, we have minus 3 over 7 times x, 7x minus 3 would be equal to minus 21. Okay, on this question again, we want to break this rational expression into partial fractions. We're going to solve b as an example. So on b, we have a negative sign. Then on the top, we have 7x minus 15. And on the bottom, we have x minus 1 squared. First, I want to get rid of this negative sign in here. So I'm just going to multiply it by denominator. And it would be equal to minus 7x plus 15 when you just multiply it by negative 1. And on the denominator, we have x minus 1 squared. This version is more clean, and I don't have the negative sign in front of the ratio. Now, I want to look at the denominator in here in order to see how can I break this expression into partial fractions. Looking at the denominator, I can see that it consists of x minus 1 squared. So it has a repeated linear factor, so it can be written as a over x minus 1 plus b over x minus 1 squared. Now I have to find the a and b value in order to successfully break this expression into partial fractions. In order to find the a and b value, as you remember, we have to get rid of the denominators. So we have to multiply both sides of the equation by the common denominator, which in here is equal to x minus 1 squared. So I have to multiply x minus 1 squared by both sides of the equations in here. So I'm just gonna rewrite the expression on the left hand side. And I'm just gonna multiply this expression by x minus 1 squared. Then I'm gonna apply the same thing to both of the other terms. So on the first term, we have a over x minus 1, which is going to be multiplied again by x minus 1 squared. On the last term, we have b over x minus 1 squared, which is again going to be multiplied by x minus 1 squared. Now I'm just gonna cancel out the similar terms. So on the left hand side, we have x minus 1 squared. These would cancel out. And on the next term, we have x minus 1 squared on the top and x minus 1 on the bottom. So we will have x minus 1 on the top. And on the last term, we have x minus 1 squared on the top and on the bottom as well. These would cancel out each other as well. Now I'm just going to write the equations in here. So we have minus 7x plus 15 on the left hand side. On the right hand side, we have a times x minus 1 in the bracket. So I'm just going to expand it. So it would be equal to a times x and a times negative 1. So it would be equal to ax minus a. And we have b at the end. Now, what I want to do, I want to match the coefficient of x terms and constants in both sides of the equations in here. So the coefficients of the x terms should be equal to each other, and the constants should be equal to each other as well. So as you see in here, by space of the x terms, on the left hand side, we have only a negative 7x, and on the right hand side we have ax, and that's it. So we can say minus 7 on the left hand side should be equal to a. Now looking at the right hand side, we have 15 as a constant, and we have negative a and plus b. So we can say that 15 from the left hand side should be equal to minus a plus b. And that one was my equation number 1, and this one is equation number 2. We have 2 equations and 2 unknowns, but on this problem, as you see in here, the value of a is already given. So a is equal to negative 7, so I can easily calculate b based off the second equation. So based off the second equation, I can say that 15 is equal to negative a, and our a was equal to negative 7 plus b. So negative times negative would be equal to positive, and if I just move 7 to the other side, that means my b would be equal to 8. So we could successfully find the a and b value, and now we can go to the top and write this as negative 7 over x minus 1 plus 8 over x minus 1 squared. So in this question again, we are dealing with rational expressions, and we want to break them into separate partial fractions. We're going to solve e on this example, and the rest can be solved at your own convenience. On e, we have 2x squared minus x plus 1 on the top, and we have x plus 1 times x minus 1 squared on the bottom. Now, looking at the denominator terms, we see that we have x plus 1 factor, which is a simple linear factor, and we have x minus 1 squared factor as well, which is a repeated linear factor in here. Each of these terms, as you see, gives us different terms in the decomposition. For example, x plus 1 factor gives us a over x plus 1 term in the decomposition, and x minus 1 squared gives us b over x minus 1 plus c over x minus 1 squared factors in the decomposition. Now what you have to do, you have to combine these terms that each of these factors gives us in order to formulate the final partial fractions. So we can say this expression is equal to a over x plus 1 plus b over x minus 1 plus c over x minus 1 squared. And now we have to find the a, b, and c value. In order to find the a, b, and c value, we have to first get rid of the denominators in here. So we're just going to multiply each of these fractions on the right hand side, and we're going to multiply the expression on the left hand side by the common denominator, which is equal to x plus 1 times x minus 1 squared. So I'm just going to write the expression on the left hand side again. Now I'm just going to multiply this by the common denominator, which is x plus 1 times x minus 1 squared. And the same expression needs to be multiplied by each of the terms on the right hand side. So we have a over x plus 1 that needs to be multiplied by x plus 1 times x minus 1 squared. And we have b over x minus 1 that needs to again be multiplied by x plus 1 times x minus 1 squared. And we have c over x minus 1 squared that needs to be multiplied by x plus 1 times x minus 1 squared. Now we're just going to simplify the expressions. So on the left hand side, we have 1x plus 1 and 1x plus 1 on the top, x minus 1 squared on the top and on the bottom as well. So these will be cancelled out. Looking at the right side, we have x plus 1 and x plus 1 on the top. And looking at the second expression, we have x minus 1 on the bottom and we have x minus 1 squared on the top, which would leave us with 1x minus 1 on the top. And on the last term, we have x minus 1 squared on the bottom and x minus 1 squared on the top. So I'm just going to write the expressions now. On the left hand side, we have 2x squared minus x plus 1. Now, looking at the right hand side, we have a times x minus 1 squared plus b times x plus 1 times x minus 1. And at the last, we have c times x plus 1. Now, as you remember from the previous examples, we used to match the coefficients of each terms in here. If we want to use the same method, it would leave us with 3 equations and 3 unknowns, which is a time-consuming process in here. So instead, we can use a method called the plug-in method. On this method, we're going to use smart values, and we're going to choose the smart values for x in order to get rid of some terms in here. As an example, as you know, this equation is valid for every x value that you can possibly choose. So I'm just going to say that if I choose x is equal to 1, right? What would be my equation on the left-hand side and on the right-hand side? So on the left-hand side, I have 2 times 1 squared minus 1 plus 1. And on the right-hand side, as you see in here, the first term, which is a times x minus 1 squared, this term would be omitted because 1 minus 1 is equal to 0, and 0 times a would be equal to 0. Also, on the second term, we have a x minus 1 term in here again, so this term would be again neglected. And at the last term, which is c times x plus 1, we would have c times 1 plus 1. So we can say that 2 minus 1 is equal to 1, 1 plus 1 is equal to on the left hand side, and we have 2c on the right hand side. So our c value would be equal to 1. Now, we can use another smart value for x in here and find the values for each side of the equation. So we say that if x now is equal to -1, what would be the equation? On the left hand side again, we have 2 times minus 1 squared minus 1 plus 1. Proceeding with the right hand side, we have a times minus 1 minus 1 squared. On the second term, we have x plus 1. And if you substitute minus 1 in here, it would be equal to 0. So we're not going to write the second term. And on the last term, again, we have x plus 1. X plus 1, if you just substitute minus 1 into it, it would be equal to 0 again. So these other terms would be equal to 0 plus 0. No need to write them. Now we're going to solve this equation. On the left hand side, we have minus 1, which is plus 1, plus 1 plus 1 is equal to 2. And we have a minus 1 squared again, which is equal to 1. So 2 plus 2 on the left hand side, which is equal to 4. And the right hand side, we have 4a. And our a value would be equal to 1. Now, on the last stage, we want to find b. So if x is equal to 0 now, what would be our equation? So if x is equal to 0, we have 0 minus 0 plus 1 on the left hand side. So it would be equal to 1 on the left hand side. And on the right hand side, we would have a times -1 squared plus b times 1 times -1, c times 1. So basically I just substituted 0 in every terms in this equation. Now, luckily we know the A and C value in here, so we can easily calculate the B value. So we're just going to rewrite this as 1 is equal to A times 1 minus 1 squared is equal to 1, which is our A value is equal to 1 as well. So this value will be equal to 1. And we have B times 1 times minus 1, which would be equal to minus B. And we have our C value, which is 1 times 1, which will be equal to 1. So our B value again would be equal to 1. So now we could finally get our A, B, and C value. We can go to the top and write this as equal to 1 over x plus 1 plus 1 over x minus 1 plus 1 over x minus 1 squared. Okay, looking at question number 5, part C, we can see that we have 2x plus 4 on the top, and on the bottom we have 4x squared plus 12x plus 9 on the bottom. We want to break this expression into two partial fractions. Looking at the denominator first, we are dealing with a quadratic expression in here. But we want to see first if it actually consists of linear factors. So if you look more deeply into the expression on the bottom, you can see 2x plus 4 on the top. And the bottom, you can see this is actually a binomial square formula, which is 2x plus 3 squared. So basically, if you just square 2x, it would be equal to 4x squared. And you square 3 will be equal to 9. And you just multiply 3 by 2x by 2, it will be equal to 12x. So on the denominator in here, we are dealing with a repeated linear factor. And on the repeated linear factors, we can say this expression would be equal to a over 2x plus 3 plus b over 2x plus 3 squared. And now we have to find the a and b values. So you just have to multiply the left-hand side and the right-hand side by the common denominator in order to get rid of the denominators on each term. So we have the left-hand side term here, and just needs to be multiplied by 2x plus 3 squared. And the same thing needs to be done on all the other terms on the right-hand side. So it would be a over 2x plus 3 that needs to be multiplied again by the same value. And on the last term, we have b over 2x plus 3 squared that needs to be multiplied again by the same common denominator. At the last, we're going to just simplify the equation in here. So on the left-hand side, we have 2x plus 3 squared on the top and bottom. These would cancel out each other. So we would have 2x plus 4 on the left-hand side. On the right-hand side, we have two terms. On the first term, 2x plus 3 on the bottom and 2x plus 3 squared on the top. So we would have only 2x plus 3 on the top. And we have a times 2x plus 3. And I'm just going to expand the bracket as well. So we have a times 2x, which would be equal to 2ax, plus a times 3, which will be equal to 3a. And we have plus. Again, on the last term, we have 2x plus 3 squared on the bottom and the top as well. So these would cancel out each other as well. And we would be left with only 1b. Now, we're going to just match the coefficients of x terms and the constants on both sides of the equations in here. So looking at the x terms, we have 1, 2 on the left-hand side, and we have 2a on the right-hand side. These are our own coefficients for the x variable. Now, looking at the constant, we have 1, 4 on the left-hand side, and we have 3a plus b on the right-hand side. So we're just going to write for the constant. We have 1, 4, and we have 3a plus b. Now, if you look at the equation number 1, which is the first equation, and equation number 2, from the first equation, we can see that our a value would be equal to 1 because 2 is equal to 2a, so our a value would be equal to 1. Now, if you just substitute the a value into the second equation, we can say that 4 is equal to 3 times a plus b, so our b value would be equal to 1 as well. Now we're just going to substitute the a and b values onto our partial fractions. So our partial fraction would be a, which is 1 over 2x plus 3, plus 1 over 2x plus 3 squared. Okay, on this question, again, we are dealing with more rational expressions and we want to break them into partial fractions. But if you look at the question more precisely, you can see that the degree of the expressions on the top is equal or greater than the degree of the expressions on the bottom. This is a little different from what we have seen so far, right? Because on the previous questions, if you remember, the degree of the expressions on the bottom was actually greater than the polynomial expressions on the top. Now, but if you look at this question in here, let's say I'm going to analyze a in here. The degree of the expression on the top is equal to 1. The degree of the expression on the bottom is equal to 1 as well. And how I actually calculate the degree is I look at the highest power of the x term on each polynomial expression in here. So the first expression in here, the highest power of the x variable is equal to x to the power of 1. And on the bottom is x to the power of 1 as well. So degree of the expressions and the polynomials on each one is equal to 1. Now, if you look at b as well, the degree of the expressions on the top is equal to 1 as well, because it is 3x to the power of 1, and we have x to the power of 1 as well on the bottom as well. So degree of the polynomials on both of them is equal to 1. Now, if we look at c in here, looking at the highest power, we have x to the power of 2 in here. So degree of the polynomial on the top is equal to 2, and on the bottom is equal to 1, because we have x to the power of 1. So the degree of the polynomial in each of these sections is actually on the top is actually greater than the bottom or equal to the bottom. In order to solve this kind of questions, what you have to do, you can say that you can actually divide the dividend by the divisor and say this one would be equal to our quotient plus the remainder over the divisor. So as an example, I'm going to solve b in here. We have 3x minus 7 divided by x minus 3. So we have 3x minus 7 divided by x minus 3. So the first thing that we're going to just divide 3x by x, which would be equal to 3. Now I'm just going to multiply 3 by the divisor in here. It will be equal to 3x minus 9 in here. Now I'm just going to subtract 3x minus 9 from our dividend in here, which is 3x minus 7, which would be equal to 2. Because minus 7 minus minus 9 would be equal to 2. So on this question, we can write this as our quotient, which is equal to 3 in here, plus the remainder is equal to 2. And our divisor is equal to x minus 3. Okay, now looking at this rational expression, we want to decompose it into partial fractions again. The first thing that we should do is we should look at the degrees of the polynomials on the top and the degree of the polynomials on the bottom. If we look at the question,
on the top we have a power of 5, which is the greatest exponent in here. That means the degree of the polynomial on the top would be equal to 5. And the degree of the polynomial on the bottom would be equal to 3. Because if we have an x2 term in here and we have an x term in here, if we just multiply these two terms, it would be equal to x cubed. That means that the greatest exponent on the denominator would be equal to 3. Now, looking at this, we can see that the degree of the polynomials and the expressions on the top is greater than the degree of the expressions on the bottom. So that means we have to use a long division in order to decompose these into partial fractions. So in other terms, we can say that our dividend divided by our divisor would be equal to quotient plus the remainder over our divisor. Now you have to just divide the expression on the top by the expression on the bottom. But first we have to expand the expression on the bottom since they are in brackets in order to continue with the division. So we have x squared plus x plus 1 times 2x plus 1. Now we have to just multiply each of the terms on the first bracket by each of the terms on the second bracket. If you do so, x squared times 2x would be equal to 2x cubed. X squared times 1 would be equal to x squared. Now moving to x times 2x would be equal to 2x squared. X times 1 would be equal to x. Now moving to the last term on the first bracket, we have 1 times 2x, which would be equal to 2x, and 1 times 1 would be equal to 1. So we can write this as 2x cubed plus 3x squared plus 3x plus 1. Now if you just now take the division, the expression on the top would be written in here. We have 4x to the power of 5 plus 8x to the power of 4 plus 23x to the power of 3 plus 27x squared plus 25x plus 9. And the expression on the bottom, which we got in here, would be equal to 2x cubed plus 3x squared plus 3x plus 1. Now what you do, you just divide the first terms. So the first term on our dividend is 4x to the power of 5, and the first term on our divisor is equal to 2x cubed. You just divide 4x to the power of 5 by 2x to the power of 3, and you write it as the first term of the quotient. So the first term of the quotient would be equal to 2x to the power of 2. Now what you should do, you should just multiply this first term of the quotient by the divisor and just write it below the dividend. So 2x squared times 2x to the power of 3 would be equal to 4x to the power of 5. 2x squared times 3x squared would be equal to 6x to the power of 4. 2x squared times 3x would be equal to 6x cubed, and we have 2x squared as our last sentence. Now we just subtract the expression that we got from our dividend. So it would be equal to, the first one would be cancelled out, the second one would be equal to 2x to the power of 4, and the third term would be equal to 17x cubed, and we have 25x squared, and we have the last two terms as well, 25x plus 9. Now we just do the same procedure that we did on the first term of the quotient. So for the second term of the quotient, we're just gonna divide the first terms in here by the divisor again. So we have 2x to the power of 4 divided by 2x to the power of 3. That would be equal to plus x. Now you have to just multiply this x, which is the second term of the quotient, by the divisor again. So x times 2x cubed, it would be equal to 2x to the power of 4. Then x times 3x squared would be equal to 3x cubed. Then x times 3x would be equal to 3x squared. Then we have x times 1 as well in here. Now you have to do the same thing again. You just subtract the new expression from the expression on top of it. So we would left with 2x to the power of 4 and 2x to the power of 4 would cancel out each other. 17 minus 3 would be equal to, let me write it in black. 17 minus 3 will be equal to 14 x to the power of 3. 25 minus 3 would be equal to 22 x squared, and we have 24x and plus 9. Now for the last sentence, we're just gonna do the same thing again. So we're just gonna divide the 14x cubed by 2x cubed in here, which would be equal to 7. And now you just multiply the 7 by the divisor in here, so it would be equal to 7 times 2x cubed, it would be equal to 14x cubed. 7 times 3x squared would be equal to 21x squared. Then 7 times 3x would be equal to 21x. At last we have 7 as well. 7 times 1. Now just subtract the new expression from the expression on top of it. That would leave us with our final remainder, which would be equal to x squared plus 3x plus 2. Now, since we got our remainder in here, and we got the quotient as well, we can move up and just write the partial fraction that we got so far. So our quotient is equal to 2x squared. Let me just write it purple. 2x squared plus x plus 7 plus our remainder, which we got at the bottom, which is x squared plus 3x plus 2, and our divisor in here, which we already got, which is x squared plus x plus 1 times 2x plus 1. Now, if you look at the expression, the second rational expression in here, this has to be decomposed into partial fractions again as well. But the thing is in here that the degree of the expression on the top is equal to 2, and the degree of the expressions on the bottom is equal to 3. Because we have one x2 term in here and we have one x in term in here, so there would be a x cubed term left on the bottom. So that means the degree of the polynomial on the bottom would be equal to 3 and the above would be equal to 2. So in order to decompose this into partial fractions, we have to use the previous method that we used to actually use on the previous questions. So that means we're just going to look at the factors on the bottom. As you see in here, we have one linear factor, which is 2x plus 1, and we have one quadratic factor, which is a reducible one because it can be actually factored into linear factors itself. So we have one irreducible quadratic factor and we have one linear factor in here. So we can now break this rational expression that we got and write it as x squared plus 3x plus 2 over x squared plus x plus 1 times 2x plus 1 would be equal to first the linear term, which would be equal to a over 2x plus 1. Then when we move to the irreducible quadratic factor in here, which is x squared plus x plus 1, and we would have a bx plus c for the other factor. Then what we have to do, we have to just multiply both sides by the common denominator to get rid of the denominators in here. So we just multiply both sides by x squared plus x plus 1 times 2x plus 1. So if you just multiply both sides by this value, we would have x squared plus 3x plus 2 is equal to a times x squared plus x plus 1 plus bx plus c in bracket times 2x plus 1. Now we have to find the a, b, and c value in here. In order to do so, I'm just going to use the plugin method in order to just make smart guesses of x and try to cancel out some terms and just find the a, b, and c value easily. In order to do so, I'm just going to say that if x is equal to minus 1 over 2, what would happen? If x is equal to minus 1 over 2, the left-hand side would be equal to 1 over 4 minus 3 over 2 plus 2. On the right-hand side, we have a times 1 over 4 minus 1 over 2 plus 1. We have 0, because if you just plug in minus 1 over 2 onto the bracket on the right, which is 2x plus 1, it would be equal to 0. So that means their multiplication would be equal to 0. And the reason that I chose minus 1 over 2 was for that reason, because this whole term would be equal to 0, and we would be left with only a value in here. So our a value in here would be equal to 1. Now, if we just plug in another smart value, such as 0 in here, we would have 2 on the left-hand side. On the right-hand side, we have a plus c as well. Now, since their a value in here is equal to 1, we can say that our c value in here is equal to 1 as well. So far we got the a and c value using just only smart values of x. Now let's choose another guess. Let's say that we say that our x now is equal to 1. What would happen is, on our left-hand side would be equal to 6, and on right-hand side would be equal to 3a plus b plus c times 3. Now you can just divide both sides by 3, and we can say 2 is equal to a plus b plus c. Now, since our a value is equal to 1 and our c value is equal to 1, that means our b value would be equal to 0. So we got the b, c, and a value, and we can decompose this into two partial fractions as well. So that would be equal to 1 over 2x plus 1 plus 1 over x squared plus x plus 1. Now, since we actually decompose the second rational expression as well, we can finalize our partial fractions and write it as this would be our finalized partial fractions. So we have the quotient first, which was 2x squared plus x plus 7 plus. Now we're just going to use the two partial fractions that we got above, which is 1 over 2x plus 1, and the other was x squared plus x plus 1, and that would be our final decomposition. Okay, looking at the rational expression here, we want to break it into partial fractions. The first thing that we should do, we should look at the degrees of the polynomials on the numerator and the denominator. Looking at the denominator first, we can say that the degree of the denominator is equal to 1, because we have 1 s to the power of 1 term in here, and that would be our greatest exponent in here. And now looking at the denominator, we have 1 s to the power of 5, and we have 1 s term in here, that if you multiply these two terms, it would be equal to s to the power of 6. That means the greatest exponent is equal to 6, so that means the degree of the polynomial on the bottom is equal to 6. Now, since the degree of the denominator is greater than the numerator, we should look at the factors at the bottom in order to break this into partial fractions. Looking at the bottom, we have two terms. The first one is s plus 1, and the second one is s to the power of 5. The s plus 1 is a simple linear factor, and it's going to give us this partial fraction, which is a constant such as f over s plus 1. S to the power of 5 in here is a repeated linear factor, and it's going to give us 5 partial fractions, which are going to be equal to a over s to the power of 5 plus b over s to the power of 4 plus c over s cubed plus d over s squared plus e over s. Now in the next step, we have to combine these partial fractions together and set them equal to our initial expression. So we can say 2s plus 1 over s to the power of 5 times s plus 1 would be equal to a over s to the power of 5 plus b over s to the power of 4 plus c over s cubed plus d over s squared plus e over s plus f over s plus 1. Now, in order to find the unknowns, first we have to get rid of the denominators. We're going to multiply both sides by the common denominator, which is s to the power of 5 times s plus 1. So if you do so, the left-hand side would be equal to 2s plus 1. Right-hand side would be equal to a times s plus 1 plus b times s plus 1 plus c times s squared times s plus 1 plus d times s cubed s plus 1 plus e times s to the power of 4 s plus 1 plus f times s to the power of 5. Now, in order to find the unknowns in here, which are a, b, c, and so on, we have to compare the terms with the same power of s in both sides. So looking at the both sides, we're first going to compare the constants, then we're going to compare the s terms, then we're going to compare the s squared terms, then we're going to compare the s cubed terms, and so on. And we can find the unknowns using this method. So looking at the constant first, on the left-hand side, we have only one constant, which is plus 1. Now looking at the right-hand side, we have only one constant on the right-hand side as well, which is a times 1. So that means our a value is already equal to 1 in here. Because if we look at the other terms in here, there is always a s term involved. For example, looking at the second expression in here, we have b times s plus 1. So even if you multiply b by 1 in here, it's going to be eventually multiplied by s as well. So you wouldn't have any constant in here. Now, moving to the s terms in here, s to the power of 1 term in here. On the left-hand side, we can say that the coefficient of s is equal to 2. Now, on the right-hand side, we have a and plus b in here. So if you just multiply a by s in here, it would be the first coefficient. And now if you just multiply bs by 1 in here, it would be the second coefficient of s in here. So we can say that since our a value is equal to 1, our b value would be equal to 1 as well. Now let's move to the s to the power of 2 term in here. Based off the s squared terms we have, so on the left hand side, as you see, we don't have any s squared terms, so it would be equal to 0. But on the right hand side, we have two s squared terms, which is b plus c. So for the b1, for the s squared terms in here, again, if you just multiply the bs term in here by s term in here, it would be equal to bss squared. So that means the first coefficient is equal to b, and the second coefficient is from this expression in here. So we have a cs squared term in here that is going to be multiplied by 1. So that would be our second coefficient. So now looking at this equation in here, since b value is equal to 1, we can say that c value would be equal to -1. Now let's move to the next term, which is s cubed. For the s cubed, we don't have any s cube on the left hand side, so it would be equal to 0. But on the right hand side, we have c plus d again. That is because if we look at the expression on here, we have, again, let me use the yellow color. We have 1 cs squared in here that is going to be multiplied by s. That means the c is the first coefficient. And for d again, we have 1 ds cube in here that is going to be multiplied by 1. So that is the second coefficient. Fourth term in here, we have s to the power of 4. And we're going to compare the coefficients again. So on the left hand side, again, we don't have any coefficients. So that means it's going to be equal to 0. And on the right hand side, we have d plus e. So d is again from ds cubed times s, and e is from es to the power of 4 times 1. So let me just move back to the previous equation. From the previous equation, first, our d value would be equal to 1, because if c is equal to -1, that means our d is equal to 1 because the equation should be equal to 0. Now, if you get the d value in here, you can move to the next equation as well. So since d is equal to 1, that means our e value is equal to -1, because d plus e should be equal to 0. Now, moving to the last expression in here, which is s to the power of 5. We don't have any s to the power of 5 term on the left hand side, so it will be equal to 0. And on the right hand side, we have f plus e, which again is the same thing. Our f value, our f coefficient comes from this term in here, which is f times s to the power of 5. And our e coefficient comes from e times s to the power of 4 times s in here. So that means our f value would be equal to 1 as well. Now, since we got all the unknowns in here, we can just rewrite the partial fraction on the top and say this one would be equal to 1 over, since our a value is equal to 1 over s to the power of 5 plus 1 over s to the power of 4 minus 1 over s cubed plus 1 over s squared plus -1 over s and plus 1 over s plus 1.